So in this video, we're going to be taking already written functions and we're going to be writing them to include a new translation. So before we start actually applying translations, we need to talk about what a translation is. So by definition, a translation is a transformation that moves the graph, and it's either going to move it left or right. It's going to move it one of those two, and or it's going to move it up or down. So you have some combination of movement going left or right or up and down. But with a translation, what doesn't change is size, shape, or orientation. So for example, you can see here that we have a triangle on the screen. If I were to apply a translation, so say I wanted to move this shape down 2, I would essentially move every single point down 2 and connect it. You'll see that it doesn't change size, it just changes location and moves that shape left, right, up, or down. Now, if you were to open up your textbook, these are the notes that you would see on horizontal translations and vertical translations. What you should already know is that horizontal translations deal with going left and right. And essentially with those, we know that there is an H value that is impacting our graph. Now, what gets a little tricky here is how we actually include this H value and apply it to our function. So here you'll see the graph of y equals fx minus h, so you can see here, is a horizontal translation of this graph. What this means is we're going to take our h value, we're going to flip it to the opposite. So the reason they're using subtraction is because we are doing the opposite of h. So if we want to move it to the right 3 units, we know that that's the positive direction, so we would plug a -3 in there. But essentially what we're going to do is we're going to take our x value, we're going to surround it with parentheses, and we're going to add in that h transformation, or that horizontal translation. And it'll make more sense once we actually do this, but these are the actual book notes. Then if we look over at vertical translation, you'll see vertical translation is our k value, which again should make sense because we know that in order to have a k value, or if we have a k value, it's going to move the graph up or down. And you'll notice here that that's added on the outside. If you think back on all of the different transformations we've done, so here we'll just do the absolute value graph for an example. This is what a, h, and k look like in there. Remember that minus h is really just saying opposite of whatever h is. So if you want to put a plus there and just remember to flip h later, that's okay. But we know that these h values are the horizontal, so they're the left and the right movements. And we know that these k values are the up and the down movement. So we can see that k is on the outside being added after the fact, and h is on the inside being added directly to x. So as we perform these transformations, we have to think very, very carefully about, is this horizontal and going inside with x, or is it vertical and is it going on the outside of the entire function and being added on later? So as I said before, if you are still confused, I promise those worries are going to go away. Once we do more examples, this starts to make more sense. So what I'm going to do to start is I am going to rewrite this equation to contain parentheses around x, so I can see where I might be adding an h value in or something like that. So I'm going to rewrite this to be f of x is equal to 2, parentheses, x. I know x is in there alone right now, but just bear with me. We're going to add it in there. And then we have the plus 1 on the outside. So now that I've got this written so I can add items in different locations, I'm going to read through. And it says write a function. And we're going to write a function g of x. We're going to change this to have the name g, whose graph is a translation 5 units down. So let's pause there. We're just going to do one at a time in order. So 5 units down. I know that movement down is a vertical translation. So what I need to do is I need to add on my k value. I'm going to move this 5 units down, which means I need to subtract 5 from the current k value, which means I'm subtracting 5 on the outside of the function, because we know that's not contained inside parentheses with x. Those are the h values that move it horizontally. So in order to apply a translation 5 units down, I need to subtract 5 from my k value. So here k is currently set to 1. If I want to move it down 5 units, I need to subtract 5. So I'm going to call this g of x like the instructions asked me to. I replace the f of x, and that equals 2. I'm going to leave the x in parentheses till I'm all done, and then positive 1 and negative 5 combined together to be negative 4. So what I've done here is I've noted that I have a vertical shift, and a vertical shift is going to take place outside of parentheses because it's outside of the whole function where that k value is located, and we're going to subtract 5 from that current k value. So that's our first translation. Right here, we have now moved this function down 5 units, and we can check that off that we are done. Now, the second translation we're going to do here is 7 units to the right of graph f. So this is where this gets more complicated. So the k values, you're just adding that number onto the outside. The h values, you have to make sure that you really get the placement right, and that's why I've added these parentheses in. So what I'm going to do is I'm going to translate this 7 units to the right. Now I really need to think about this with my h value. So I know this is going to impact h because h is that right movement. And I know going to the right 7 units means I'm moving in the positive direction 7. However, I also know that when h is in my equation, it's going to be the opposite of that. So if I'm moving in the positive direction 7, the number that's going to go into my equation is a negative 7 because I need it to be the opposite of what I expect. So now I'm ready to add this into my equation, and this can get a little tricky because x is inside parentheses, and we have to very carefully add this in to the equation. So here you can see I added parentheses to my x, and here I'm going to subtract 7 from x. So in doing so, by subtracting 7 from x, I'm applying my h value, and my h value is now going to move to the right 7 units. So my new equation here is g of x is equal to 2x minus 7. We can see that movement 7 units to the right. And then minus 4, we can see we took our original graph and we shifted it down 4 units. So that's our first example, seeing how we can add in those translations, moving up and down and left and right. So let's dive in and try another example using our quadratic function. So here you can see we have a quadratic, we have an a value and an h value. We don't have a k value, which just means it's plus 0 over here on the outside if we don't have one. You can write that or not write that, it's totally up to you. And we need to translate this function. So we're going to write a function g whose graph is a translation 8 units to the left. So we're going to start there. And I'm going to bring this function down here. And we can see we already have some parentheses in there, which is really nice. I'm going to add my plus 0 onto the outside just because I like to have it there so I can work with it later. And we're going to start by translating 8 units to the left. Now I know that this is going in the negative direction 8. And because I'm moving in the negative direction to the left, remember this is going to be our h value. And we need to put a positive 8 into our equation in order to move it 8 units to the left because 8 works the opposite. Or h works the opposite. So here what we're going to do is we really have to think through this because we want to take the current function and move it 8 units to the left. So what that means is we need to add 8 to our x value. Now I'm going to do this in a way that seems a little confusing, but on the next slide why I'm doing it this way will make more sense. So we need to add 8 to x. So I'm going to do a parenthesis and do x plus 8. And then I have my plus 5 still with the squared and plus 0. I know this looks weird, but it will make more sense once we have maybe a number in front of that x value. So I'm moving 8 units to the left, which means I need to put that plus 8 into parentheses with x. Now, what's nice about this function is because x doesn't have any sort of coefficient, this turns into x plus 8 plus 5 because there's nothing to distribute, and this turns into x plus 13. So you can see that we ended up taking our h value and we added 8 to it, and that's going to move it 8 units to the left. Now, the second thing we need to do as we finish writing this function with the name g is we need to translate 7 units down. This I know is going to impact my k value. And because k works as expected, I'm going to subtract 7 from my k value, which is over here. So I'm going to take 0 and I'm going to subtract 7 from it over there on the outside. So my final function here is going to be f of x is equal to -3 times, we have x plus 13 all in parentheses, so we can see that we moved 8 units to the left. And then we have 0 plus -7 is just -7, so we have -7 here on the outside. Now, we have to make sure we read instructions carefully. This one wants this function to be named g of x, so I'm going to rename it to be g of x, and I have now applied both of my translations. So let's do another example here, and this one is going to be a little bit more complicated. You can see I added this 2 here in front of the x. Adding that 2 inside the absolute value symbol in front of x is going to complicate this a little bit. So we haven't been exposed to functions like that before. We will be in this chapter. Those are actually called your b values. We're going to slowly ease you into them. But we need to be very, very careful when there is a number in front of x, because it does change how a translation can occur. So we're going to just start by rewriting this down here so we can see everything. So we have a -1 out in front for our a value. I'm going to write -1 just so I remember that's my a value. I have 2x minus 8 inside of those absolute value symbols, and then I have plus 6 on the outside. So I'm going to read through my instructions, and it says write a function g whose graph is a translation 7 up. So I'm going to start there. 7 up, I know, is my k value, and I know my k value happens on the outside here. So k is on the outside. It's that number outside of the function, outside of the parentheses squared, outside of the absolute value symbols. So here, I'm going to apply that 7 to this 6. So here it says a translation 7 up, and k works just as expected, so I'm going to add 7 here. So now if I rewrite this, I'm going to name it appropriately here and name it g of x like the instructions ask. So we have -1 times, we have 2x minus 8 plus 13. So I've now applied this first translation right here. Now, where this one gets tricky is this translation to the left, okay? So here is saying we have a translation to the left, and we're going 6 units left. Now, hopefully you're thinking, okay, that's an h value, 6 units left. I know that that's the negative direction. So inside of my equation, I'm going to add a plus 6. Good. I am thrilled to hear that your brain is processing that you know that you need to add a plus 6 into the equation. What gets tricky is how you add this in, because you need to make sure that this gets applied to every x value correctly. So what we need to do is we need to put little parentheses around x right here. And what we have to do in order to apply this translation is we have to add 6 to x inside of everything that's happening to it. So I'm going to rewrite this so you can see what is actually going on here when we apply this translation. So we have -1, I have this 2, and I have x all by itself, and I'm doing x plus 6 in parentheses, and the -8. So while I wish it was just as easy as how we just add 7 to the k value here like we did when we went up, applying that horizontal translation is more challenging, especially when you have a b value in front of your x like that. That's inside the absolute value with it. So when we apply a horizontal translation, it needs to be applied to x, the input value. It's going to be applied to the inside, and inside means that you surround your x with an extra set of parentheses and you add that plus 6 in there. Now, what we need to do is we need to simplify this. So we're going to take the 2 and we're going to distribute it. So we have 2x plus 12 minus 8. And then inside of these parentheses, it eventually becomes 2x plus 4. So we can see that when we apply a vertical translation, this is really easy. All we have to do is apply that change over here. But when we apply a horizontal translation, we need to add it to x all the way on the inside here. We need to add in this case, 6 to x on the inside, distribute the 2 in front of the x, and then combine any like terms that we see. So if you are still struggling with this, that is okay. We will practice in class, but this is the general idea behind it. You add on the outside for a translation up and down, and you add on the inside for a translation left or right. And inside means you go all the way in by x, and you add it to x, and then distribute and combine like terms as you see fit. All right, one more quick example here of a more complicated example, and then we will be done. So here you can see that I have a quadratic because I have the squared. And if I read through, it says write a function g whose graph is a translation 5 units up. So we know that going up means this is a k value, and because up works as expected, we're going to add 5 to it. Because it's a k value, all we have to do is add 5 to that number on the outside of the entire function. That will move the entire result up 5 units, and our graph will be in the right spot. So here we would have g of x is equal to, we leave the whole entire front part alone, and this just becomes plus 14. So we have now added in that up 5. Now, the second translation we need to do is we need to move 6 units to the right. So we're moving 6 units in the positive direction, which means when we change and try to impact our h value, we're going to put a -6, or the opposite of what we expect, into our equation. Now again, remember, this is very tricky. We don't just add it inside the parentheses. We have to add it to x and then distribute as needed and combine like terms. So here we're going to take 3. I have -2. I'm going to put a parenthesis there. And I have x minus 6, so notice I'm adding a -6 to my x. Don't forget my plus 4, and then I can put my squared. So notice here that I have added where my x is, you can see it right here, x, and then I added that -6 in order to move the graph 6 units to the right. Okay, so that's my first step. I add it all the way inside of there to x. Now, I need to simplify this portion underlined in purple. That means I need to distribute, so I have -2x, and then -2 times -6 is a plus 12, plus the plus 4, and then I need to combine like terms. So inside of my parentheses, if I want to apply a translation to the right 6 units, it turns into -2x plus 16. So again, note where I added that subtraction of 6. It's inside, super inside, added in with x. And then from here, I can keep my plus 14 on the outside, my 3 on the outside, and I have my new function. So again, just being really careful. Up and down, you just add to the outside, but if you're translating left or right, it has to be inside here with x. And you have to add in a set of parentheses and then distribute and combine like terms as you see fit.